dear people, today we'll be looking at the lab Tune Gemini Model by using Supervised Fine-tuning. Once your lab is ready, let's go ahead and open the GCP console. This will take about 20 seconds to load. Make sure you open it in a new incognito window. You can go ahead and click the I understand button if you're asked for any terms and service agreements. Click Agree and Continue. Now that our GCP console is ready, let's go back to the lab and check what our first task is. So let's scroll down below. We see our first task is to create the cloud storage bucket. So let's go back to the console. Let's go ahead and activate the Google Cloud Shell. This is going to ask you to continue. Let's wait a couple of minutes. It'll ask for authorization. Go ahead and authorize. It should take around 10 seconds for the shell to get provisioned. Once this is provisioned, let's go ahead and paste the command to create the cloud storage bucket. You can find all the commands within GitHub, and you can find the GitHub link in the description of the video. Make sure to change the bucket name and region in the first command according to your custom lab, as you see here. Let's now go back to the console. We will go ahead and paste the first command. Once we are done, let's come back and check progress. So we see that this is completed. Now our task 2 is to deploy an AI workbench. So let's come back to our console. Let's close gcloud. Now on the search bar, let's type Vertex AI Workbench. So here we see the workbench option. Let's go ahead and select the workbench. The interface will take half a minute to load. Once the workbench interface has loaded, let's go ahead and click Create New here. Let's go back to our lab and check the name. So let's copy the name required for the workbench, come back to the console and paste the name. We also have to check for the zone. So here we have Europe West 4C. So let's go ahead and select Europe West 4C as well and go ahead and create the workbench. The creation of the workbench will take up to 3 minutes, so I'll go ahead and forward until the workbench is completed. Now you see the workbench is created. Let's go back to our lab and check progress. This says step is completed. Next task is to copy the Jupyter notebook within the workbench instance. Let's go back to the GCP console and click Open the Jupyter lab. This will take a couple of minutes to load. Once you see your Jupyter lab loading, let's go ahead and select a Python 3 terminal. Now here we'll have to paste the second command, which is on GitHub, within the commands.md file. Replace the template link on GitHub command to the template given here on your respective lab. Paste it and run the command, and it will copy a workbook into your workbench. Once we see this file is loaded, let's go back to our lab and check progress. So this is complete. Now our next task is task 3, which is to generate the training and evaluation dataset files. Let's go back to our Jupyter notebook and open the notebook which was just copied. Now let's start running the cells in these notebook one by one. Run the first cell. It'll take a minute to complete. Once it's done, let's go ahead and continue running the next cells. Once we reach the cell with the SQL query, we have to change the to do in the final line to 550, or whatever is asked in your lab. Now let's run this. We will run the remaining cells.
In this cell, change the to-do portion and assign value 0.2 to the variable test size if the percentage is 20, 0.3 if 30%, and so on. For my lab, it is 20%, so I will make it 0.2.
After running this cell, we see an instructor here to go back to lab and check progress. Let's do that. Go back to your lab, check progress here. The note here says that we need to save the notebook file. So let's go back, save the notebook file, and try progress check again. Perfect. Now this step says it's completed. Now our next step is to prepare training and evaluation JSONs. Let's go back to our Jupyter notebook. Let's run the cells one by one. You can also click Shift plus Enter to run the current selected cell. Let's run this cell. Let's run the next cell. We'll run this cell as well. Now we'll run this cell. We'll go ahead and run the next cell as well. Now, as we reach here, we have instructor to check progress of the task 4. So let's go ahead and confirm if this is complete. So this shows it's complete. Now our next task is task 5. So task 5 is to start a supervised tuning job using Gemini. So let's go back to our notebook and we'll run the remaining cells. For the foundation model, make sure that you have the foundation model as the same as which is mentioned in your lab. Let's go ahead and run this. So this one is the next main cell. So you have to insert your code to start supervised job here. So before you run this, you have to do one more thing. Insert a cell above this cell and add the code from the first cell in the GitHub Python notebook. Paste the code and run. Now you can go ahead and paste the next code for creating the supervised job. Before running this cell, make sure all the variables are correct according to your lab. Check for the location, the epochs, the learning rate multiples. Once you're sure that this is according to your lab, go ahead and run the cell. So when you run this cell, it will give you the link of the tuning job. You can go ahead and click the link. It will show that tuning is pending. You can go to the details, and you have to wait until the status turns to running. Once you see the status as running, let's go and check progress. So this will show that this step is completed as well. Now the tuning job itself is going to take almost 90 minutes to 2 hours to get completed, so you can go ahead and take a break until then. I will fast forward this recording training until the job is complete.
Now, to check the job completion, you can go to the link in the notebook. Now here you'll see succeeded once the job is complete. Once you see success, you can come back and check progress, and it will tell you that this task is completed. So now you have completed 90 out of 100. You can go ahead and end the lab.
That's all for this video. Thank you for watching. Until next time, bye.